Welcome. So in this lecture, we're going to talk about writing infinite sets with patterns. And for example, and what we're going to look at, like the set of all even integers or something like this. And this is one of these things where there's kind of like a slick answer, which is a little confusing, but you're going to get used to that kind of notation. But there's also another way to, sometimes you want to write things out just so it's like clear to whomever's reading what you're writing exactly what you mean at like very quickly. Okay, so here's kind of like the underlying question of this particular lecture is that how do we write the set of all even integers? So we want the set of all, but we're not looking at all integers, we're just looking at all even integers. So all even integers. Okay, now so here's kind of the slick answer, and it's good to know how to do this. And once you start getting very comfortable with all these kinds of symbols, you're going to want to write things often in ways like this. It also kind of is easier to work with. So here's the slick answer. So the integers are precisely everything you get when you multiply all the integers by 2. Okay, so let's kind of like write this like this. So this is the set, right? This is like the set of all. And then I would write 2k, so this is kind of the form, right? So the set of all, so we have 2k, so that, and then you'd have x is in the integers. And notice this looks a little different than how some of the ones we've done before, but it still works with this notation, okay? We're looking at 2k. It's a little funny. We are setting the variable's at k. What is k allowed to range over? It's going to range over all the integers, so 6 is 2 times 3, so the k would be 3, or something like this, okay? So this is the set of all, so let's kind of write this out. So this is like the set of all. So this is the set of all, and then like the 2k, right? The set of all 2k, satisfying that we have that k is an integer. Right. This is kind of what this notation means here. Okay. So let's kind of look at it. But this is like the slick answer. But it might be a little difficult to understand. It's useful, but maybe a little difficult to understand. Okay. So here's a much easier to understand example. Or way of writing it. Okay, is that we could write, so I'm going to put a bunch of dots here, which says I'm going to go infinitely far in that direction, and then I'm going to start going through integers like -4, -2, 0, okay, 2, 4, maybe also include 6 here, who knows, and then I just keep on going like this. Okay, and I put dots to kind of indicate that I keep on going and make sure I make them nice and big to make sure they're very clear to you that there are dots there. I think the ones on the other side are a little bit clear. Okay, so let's kind of break this down. So what did I do there? So breaking it down. Okay, so what do we have going on there? So we need dots, right, to indicate that the pattern continues on forever. Okay, so we need dots to indicate that the pattern continues on forever. So indicate that the pattern continues forever. You don't ever stop listening numbers as you go in that direction, but they have to still fit within that pattern, okay? And then the other part is that we needed to include enough elements, right? So I had to do, and also important here was I had to do dots on both the right-hand side and the left-hand side, right? To indicate that I'm going to continue infinitely far forward and infinitely far backward. The other thing was I needed to include enough elements to make the pattern clear. So I needed to include enough elements to make the pattern clear. Okay. So what would be an example of where one might fail at that? Okay. Is if I had, for example, I just wrote 2 and then 4 and then continued on in the forward direction. Okay. You wouldn't know whether I was talking about positive even integers. So this could be, well, I could be talking about the positive even integers. Right. Or what else could I be talking about? I could also be talking about positive powers of 2. Right? Right? Because this is like 2 to the 1, and then I have 2 to the 2, and then 2 to the 3, and so on. Okay? So this is a nice, convenient way, if you can, right? You can't do this with the real numbers. I can't just list them like this. But I could for something like the even integers, and it makes a lot more sense to the looking at it a lot of the time than something like this, even though this is very useful and compact and nice and slick notation. And the kind of key points, there were kind of 2 key points. One was make sure that you're putting dots to make sure that people continue on to the right and the left when they need to. In this circumstance, notice I put them on the right, not on the left, because in this circumstance, we would not continue on the left. Okay, and the other part of it is that you need to include enough elements to make sure that the pattern's actually clear. Like in this example, this could have more than one meaning. Okay, so I hope that made some sense. And I'll see you in the next lecture.